Hey, folks, welcome to More Than a Refresh, the T3D sessions. Today we have Sugu with the Multigres project. Sugu, tell us about yourself and the project.
My name is Sugu. I am currently the head of Multigres at Supabase. I am leading the effort to build Multigres, which is an adaptation of Vitess for Postgres. Previously, I'm also the co-creator of Vitess, which a project that we started in 2010, which is now over 15 years old and has been adopted in various enterprises. And I also previously co-founded PlanetScale, after which I went on a pretty long sabbatical. And I recently decided to come back and work on this project.
Yeah, I considered a sabbatical recently. They are a double-edged sword. Um, I've been doing Postgres for so long, as you know, that I toyed with the idea of actually handing the reins of my company, Command Prompt, completely over, and going and get a quote unquote job.
Wow.
Um, yeah, yeah. And I talked to a lot of people I know and trust and love, and they very gently reminded me that I haven't had anybody that's been allowed to tell me what to do for 3 decades. That puts a crimp in the idea of being an employee, so, I kinda wrapped myself back around and reinvested in PostgreSconf and as well as Command Prompt, and things are looking pretty good. But, d d talk to me about Multigres. What's the problem it solves?
So Multigres solves in some respect, the problem that I'm solving is what I solved for the MySQL community earlier.
Mhm.
Uh, The good news is it's a problem that people have not seen yet in Postgres because Postgres hasn't seen the kind of adoption that MySQL saw like 10 years ago. So I've been through that journey when I was at YouTube. I saw the growth, the kind of explosion in data that can happen in databases.
Mhm.
And while I was in sabbatical, I noticed that same upward curve happening to Postgres, and I knew where that was headed. And when I looked at the ecosystem, I realized that there is nothing like Vitess for Postgres, and no one has built it yet. And that's when I decided, somebody's got to do this, so I'm going to do it since I've built Vitess before. Is essentially what inspired me to start this project.
So what's the architecture like? How does it help us deal with large I mean, there are a few very large installations out there, but they're usually heavily modified and they're really only Postgres like by dialect, right? The storage engine's been completely replaced. So how does yours work?
Correct. So there's a few things that I think are important, at least in terms of scalability, as far as scaling well is concerned. One thing is leveraging what is good and what works well, which is Postgres itself. Postgres itself, and so my idea of scaling is leverage the fact that Postgres is good. So in other words, what I want to do is actually shard Postgres itself, not replace it.
Okay.
So that is
And
one. Yeah.
are we doing that through a broker or are we actually re-engineering the protocol or how is it that we're doing that?
It's essentially the broker is a more correct term. It's actually
Okay.
what happens is it's a proxy that sits in front of Postgres that also understands your query, but then can decide, oh, this data is in that shard. Let's send the query there.
Okay. So in that vein, and obviously I'm not sure you're attacking this market, but in that vein, it would be similar to say Greenplum or PostgreSQL.
I'm not familiar with how they work.
Okay.
Uh, yeah.
So Green Plum is an MPP, right? So there is a broker you connect to, and it knows which node or shard that
Oh,
the
so
data
that
is
sounds
in.
very similar. Yeah.
Uh,
Shared nothing architecture is that
Correct.
what it
It is
is?
a
Yeah.
shared
So
nothing
yes,
architecture.
correct. This is
So
also a shared nothing.
Cloudberry would be another one, right?
Correct. Okay. So it's
Um,
yeah, yeah.
but the difference here is Cloudberry and Greenplum both, at least in their history, are really more geared toward OLAP, not OLTP. What's your target?
My target is 100% OLTP.
Right. Okay.
Very
So
very
that's more
little
of
of
an
OLAP.
XC. Yeah, that's how XC would operate.
Got it. Got it. Yeah.
Okay, so you got a shared nothing architecture. So we have nodes that have pieces of the database. How far have you progressed? I mean, where are you on the success scale of this?
We are barely getting started. Essentially, I joined Supabase last June. It took me a few months to put the team together. I think we probably got the team together around September or so. So we are about 3 or 4 months into the project.
Mm.
And we are building actually the foundational pieces. So this is the thing that is important to know. Sharding is actually only 10 or 15% of the effort to actually scale Postgres.
Oh,
The
sure. Yeah.
the complex part is actually the ecosystem that you have to build to maintain that sharded system. And that foundational part is what you have to build first. And that's what
Well,
we are building.
the biggest part I would imagine, and I I say this so like it's so simple. Um, One of your challenges, since you're going after OLTP, is the visibility. So you have this scenario where, and correct me if I say anything wrong, but as I understand it, the issue that you're going to run into is on a transaction that touches multiple nodes. That transaction must be either the same transaction, that's one way to do it, that is aware of itself, or the other way to do it is that you have to open a snapshot for each micro transaction across each node and make sure they're in sync when you commit.
Correct, correct. Yeah. It is
Which
a
approach are
very,
you
very
taking?
difficult problem to solve.
No,
So,
yeah,
yes.
it's so it's funny because it's not unlike the multi-master problem. In fact, I would argue in some ways it's more complicated than a multi-master problem because a multi-master problem, you still keep each database has a whole copy, right? Whereas with the sharding situation, you could have 20 different sections of the database.
Correct, correct. So this is where the art of sharding comes into play. So if you look at uh, massive scale workloads, they are not they are usually not what do you say completely crisscrossed.
Right,
Especially if a company grows very big and the data becomes huge, if it reaches hundreds of terabytes, you will actually find groups of data that are related together. Like the best example I can give you is if you have somebody who's running an e-commerce site, they would have merchants,
right.
tenants, and so we rely on that fact that you can identify pockets of data that are related together and keep them together within a shard, which in 99% of the cases completely avoids distributed transactions.
Right.
And when you use that as foundation, saying that most of the time the queries that you run will end up in just a single shard, most of the time the transactions you create will end up being just within one shard, then such a system will be efficient and simple at the same time.
Right, but the issue there though is building I mean, this, but the issue there is building the infrastructure to understand your rights. And
Correct.
that's actually not that complicated, right? Because you're going to have the parser and the planner, knowing where things are going. The problem comes in is that if one node, a write ends up moving the data to another node. Because then you got to make a decision, right? You got either A, do I basically fragment this one node, or how do I efficiently move the data to the node it now belongs without compromising performance?
Are you talking about this happening during a transaction or in general? As
Well, I mean, either way, right? So let's talk about from an actual operation. So, like you said, e-commerce. We've got merchants, so we know that merchants 1 through 10 are on one node, merchants 11 through 20 on another node, so on and so on and so on. You're right. That works, and it works well because you know that pretty much all the time, merchant 1 through 10 is going to be on node one.
correct.
Okay. Now that's beneficial unless the problem that occurs there is twofold. One is if merchant 6 all of a sudden becomes more power or more data
Yes,
than what the other 9 can handle.
correct, correct.
Okay. So
Yes,
how do you break
yeah,
that off? That's number one. But the other problem you have is what if merchant 6 gets acquired by merchant 18?
correct.
And you got to move their data. So
Yeah,
we can do it on the back end, right? You can have an agent that like pulls around and figures things out. That gets even more complicated and all with open visibility maps. Or you have a situation where the transaction as it commits will move a merchant,
yeah,
right? From one
yeah.
node to the other. It, this is so, I mean, like I said, you know all this, but what I love about this is people will, you and I, we're in the deep part of this stuff. And you talk to someone, you're sitting around a conference table or something, and you're having a glass of wine, and some guy or gal's like, I don't understand why we can't just do X. And we've just in 12 minutes, we've been talking for 12 minutes, we have talked about years worth of algorithm and code being written to solve that problem, to only do it partially correct.
Correct, correct.
And they
Yes.
don't understand that. All right. So is
So this,
multigress, is it open
yeah,
source?
this specific problem, for example, is the when I told you about the ecosystem that you have to build before you can
Right.
get sharding to work. This is one of those problems that we have to solve, which is how do you reshard? How do you break up shards into smaller
Mhm.
parts without incurring downtime, without losing consistency, for example?
Yeah, well, certainly. And it's the first problem that you and I discussed, which is you know, merchant ID 6 needs
Correct.
to
Yes, that's the one.
needs to
Yeah.
migrate to its own node. That one's actually relatively simple, right? I mean, and I
Correct.
do
Yeah.
mean relatively, right? But the other one is a much bigger problem.
It's
Let me
easy to explain and for someone to understand. There's a lot of code that has to go behind it to make sure that it happens correctly. But at a logical level, it's quite easy to explain how that should
correct.
work. Correct. Yeah.
Is Multigres open source?
Yes. Multigres is open source.
Awesome. Glad to hear it. As we close out, this has been another T3D session from More Than a Refresh. Sugu, is there any final words you'd like to give about the Multigress project?
I am very excited about it because mainly the part that I'm most excited about is how excited the community is about this project. I did not expect this much excitement around the fact that we are building Multigres, and it kind of validates my decision to come back and build this. So yeah, I really feel grateful that this happened.
All right. Well, I wish Supabase and Multigress all the best in the world.